the force tangentially, and the total length, normal length is L. So that what we have taken, tan phi is equals to x by L. At very small angles, what we have taken, phi is equals to x by L. And yesterday we have solved one problem that we have taken angle as 30. At that time what we have taken? We did not take that as a phi, we have taken it as tan phi. Why? Because angle is there already, angle is not very small. So we have discussed about the stress like that, and then strain, and also stress. If you see the stress nothing but what is the formula we have discussed? Force divided by area. That force will be which force? Restoring force or deformation force. Restoring force or deforming force divided by area is the stress. In that we have two stresses. One is what? Which type of stress? Normal stress. Another is shear stress or tangential stress. Normal stress means, in normal stress what happening? Force is acting perpendicular to the surface area or perpendicular to the cross sectional area. That is a normal stress. And also in case of shear stress or tangential stress, the force was acting tangential to the surface area. That was the shear stress we have discussed. In the normal stress only, again we had two types. One is longitudinal, another is volumetric or bulk stress. So longitudinal nothing but what we have discussed, the force is acting perpendicular to area only, but it is acting along the length of the body. Longitudinal nothing but force is acting along the length of the body, but it is acting obviously normal to the surface area only. And that is about the longitudinal stress. That might be elongate extension, otherwise that might be in compression. In any case it is possible. And also next one is volumetric stress or bulk stress. Volumetric stress nothing but the force is acting from all the sides, either to decrease the volume or to increase the volume. So that was the volumetric stress. In each and every case, what was the formula for us? Force by area only, however, that is acting in different directions, so only we got different types of stresses there. In case of tangential force divided by area you have to take, that is about the tangential stress. And before that we have discussed about the elasticity, that is normal, already you know the definitions. Elastic bodies, plastic bodies, and also rigid body. These and all we have discussed yesterday. Now we will see the Hooke's law. Hooke's law. See, very small chapter, I think I will finish it by tomorrow only. So very small chapter, compulsory one question will come. Compulsory one question will come every year. So easy questions only will come, you can solve that easily. And also in this, after the Hooke's law, in the Hooke's law only, in the case of Young's modulus and all, that will be related to the work power energy. In case of work done to stretching the wire, otherwise energy stored in stretching the wire, and then elongation due to the own weight, like that little bit related to the work energy will be there. Normal, F is equals to W is equals to integration of F dx formula based. And also next one is, when you take the bulk modulus. Bulk modulus nothing but I said volumetric stress or strain will be there in which type of materials? In which type of materials? Fluids, I said. In case of liquids and gases, volumetric stress will be there. So that bulk modulus and then rigidity modulus will come in related with the fluids chapter. I think but just pressure formula based. That is H rho g. Pressure is equals to what is the formula? H rho g only, right? Based on that some formulas, some problems will come in that. That's it. Then we can finish the chapter by tomorrow only, but one question will be there compulsory. You have to learn it, and very easy. Whichever the assignment I have given, I think I have given 170 problem nearly. So those are more than enough for this. You can solve it and then you can get it easily. Clear? Then Hooke's law. Hooke's law nothing but, what is the Hooke's law statement I said yesterday already? Stress is directly proportional to strain. Hooke stated that stress is directly proportional to strain. Stress nothing but what is the stress means? Force acting per unit area. If I increase the force, for example, if I take this as a wire, if I increase the force on this, then what happens? Elongation also increases. Elongation is increasing nothing but strain is only increasing, right? Elongation nothing but what? Change in dimension. Change in dimension is increasing means strain is increasing. So whenever I increase the stress, whenever I increase the force on this, then strain also increases. And nothing but elongation also increases. So stress is always directly proportional to the strain. Whenever you are increasing the more stress, at that time there will be more elongation or there will be more compression in the body. So Hooke stated that stress is directly proportional to strain Then whenever I remove this proportionality, I will get a constant E. That E is equals to what I can write here? Stress divided by strain. What we call it as? Modulus of elasticity. Modulus of elasticity is a E. The stress, Hooke states that stress is directly proportional to strain. Then I can remove the proportionality by taking a constant. That constant is known as what? Modulus of elasticity. Modulus of elasticity is equal to stress by strain. In different cases, again like a strain only, it will also have three types. One is whenever it is changing the length, at that time one modulus will come. Whenever the volume is changing, at that time another modulus will come. Whenever we are applying the force tangentially, at that time another modulus will come. Whenever we are talking about the change in the length, at that time we will take it as a Young's modulus. Nothing but we will get longitudinal stress by longitudinal strain. Why? Because we are talking only about the length. Whenever you are talking about the volume of the body, at that time volumetric stress by volumetric strain, we call it as bulk modulus. Whenever we have taken the tangential stress by tangential strain, that we known as rigidity modulus or shear modulus. These are the three types of modulus of elasticities will be there. And also whenever I say if the elasticity increasing, whenever the elasticity increases, at that time we can say that the material is more elastic. Whichever the material is having more modulus of elasticity, that material is more elastic. In reality, as compared to rubber, steel will have more elasticity modulus. So that what we can say in practical, generally whenever you stretch the rubber, at that time it will elongate more. Whenever you are stretching the steel, it will not elongate. But in practically what happens? Nothing but the steel is more elastic than rubber. You have to remember that. Theory question important. Steel is more elastic than rubber. What is the reason? Nothing but the elastic modulus of the steel is more than the rubber. Whichever is having more elastic modulus, more modulus of elasticity is there, that is more elastic. So here whenever you compare the rubber elasticity modulus and then steel elasticity modulus, steel will have this modulus of elasticity more. So that what I can say, steel is more elastic as compared to rubber. So whenever you are stretching, you can stretch easily rubber, but which is more elastic? Nothing but in that also, whenever you are what is the reason why it is happening means, whenever you stretch the rubber with more force up to a longer elongation, at that time what happens? It will breaks, but steel will not break. So in that again two types of materials will be there, brittle and then ductile materials. I will tell about that. Whenever I explain the graph, then I will tell you about that. So whenever you compare the steel and then rubber will break easily, but steel will not break easily. So only the steel is more elastic than rubber. It might be stretching easily, but what happens? It will break that much easily only. But whenever you compare the steel, it will not break. So it will just elongate, it will not break that much soon. So only this one is more elastic than this one. And this one is a ductile material, this one is a brittle material. We will discuss about that, okay. Write that, Hooke's law. Hooke's law states that stress is directly proportional to strain. Stress is directly proportional to strain. TG, pause the video. Very with high the materials with high modulus of elasticity, the materials with high modulus of elasticity are more elastic. Write a note point. Steel is more elastic than rubber. Steel is more elastic than rubber. That point is important. Steel is more elastic than rubber because the modulus of elasticity of steel, is more as compared to rubber. Is more as compared to rubber. Very important point that one is. Next one is, this modulus of elasticity will be again 3 types. One is whenever you are talking about the length, at that time which modulus of elasticity will come? In case of length, Young's modulus. In case of volume, bulk modulus B. And also in this one more thing will be there that we call as compressibility. Bulk modulus or compressibility. One more thing will be there. Then whenever you are talking about the shear, at that time that is shear modulus or modulus of rigidity. Young's modulus in case of length, and then bulk modulus in case of volume, shear modulus or modulus of rigidity in case of the tangential stress and then tangential strain. So that here Young's modulus that is Y is equals to, what is the formula I can say then? Longitudinal. About the length means which stress will come? Longitudinal stress. Which strain will come? Longitudinal strain. So that longitudinal stress divided by longitudinal strain. That is the Young's modulus we will get. Next, whenever you see the bulk modulus, B means here bulk modulus. So what is stress and then what strain you will get? Volumetric stress divided by volumetric strain. Then in case of shear or tangential, what we call it as? Nothing but we call it as rigidity modulus, rigidity or shear modulus. So that is neta is equals to what we can get? Tangential stress by tangential strain or shear stress by shear strain we can write. Shear stress divided by shear strain. So here whenever you come to the Young's modulus, what is the longitudinal stress formula? What is the longitudinal stress formula? F by A, that might be any stress. What is the stress formula? F by A only, force by area, F by A. And then longitudinal strain formula is what? Delta L by L. So that delta L by L. And also this delta L we can call it as even elongation, that I can denote with small e also. Okay, in some problems they will denote with small e also. That is the meaning of elongation or delta L. Everything is same only. So what is the formula I can write easily here? FL by A into delta L or FL by A into E. E is the elongation here, extension or elongation, that will denote the delta L value. Okay, that is about the Young's modulus. Whenever you come to the bulk modulus B is equals to, what is the volumetric stress formula? Force by area. Force by area is acting in one direction or all the directions? All the directions. Whenever force is acting from all the directions, what is getting developed in the body? Pressure. Force is acting only one side, nothing but at that time stress will be there or tension will be developed in the body. Whenever force is acting from all the directions, at that time what will be developed? Pressure will be developed. So that pressure P divided by volumetric strain formula is what? Delta V by V. And also tell me that one important thing I will ask here. Whenever you are increasing the pressure, at that time what happens to the volume? Volume will decreases. Whenever I am increasing the pressure from all the directions, then what happening? Size of the body is decreasing. So that volume is decreasing. So that minus delta V by V. Clear? So here I can write it as, whenever I say the modulus of bulk modulus B. Okay, B is equals to what I can write here? P by delta V by V. That is a bulk modulus formula. So here this minus indicates that whenever I increase the pressure, then what happening? Volume is decreasing. And also in this one more will be there, that is we call as compressibility. Compressibility denoted by C. The C is exactly equals to the reciprocal of bulk modulus. Reciprocal of bulk modulus is known as the compressibility here. So what is the formula I can write? C is equals to delta V by V divided by pressure P. That is what I can write here. So that is about the compressibility and then bulk modulus. Next one is shear modulus. shear modulus or tangential, otherwise rigidity modulus. So that what I can write here, shear stress means what is the formula? Shear stress means what is the formula? Force by area. Which force you have to take? Tangential force by area. So that force divided by area, that divided by shear strain is what? What is the shear strain? X by L. Shear strain is X divided by L. Then what I can write here? FL by A into X. Otherwise, one more formula of this one is F by A divided by X by L, nothing but what? Shear strain, what we denote with phi, right? Whenever the angle is very small, then we will take it as phi. So F by A divided by phi is a shear modulus here. Listen again. Listen, later on we can write. First of all, listen. In modulus of elasticity, I said that whichever the materials will have more modulus of elasticity, they are more elastic as compared to the other materials. So here I said very important that steel is more elastic than rubber. So why? Because steel elasticity modulus is more as compared to the rubber. Whenever you come to the fluids, we will have bulk modulus there. So that bulk modulus will be what? B here. In case of materials, we will get the longitudinal, otherwise Young's modulus or rigidity modulus. Whenever the length of the body is changing, at that time which modulus will come? Nothing but Young's modulus. Nothing but linear bodies if I take. For example, if I take the wire, on the wire which modulus I can apply? On the wire, very small wire I have taken, very thin wire. Young's modulus only. Why? Because shear modulus is not possible. I cannot displace it. Whenever I apply the force tangentially, then what happens? It will get bended. So I cannot apply the shear modulus there. And also bulk modulus is, however, it is not possible. Why? Because whenever I cannot apply the force from all the directions. I can apply only force from only one direction. So that which is changing there? Length is changing. So that clearly I can say that Young's modulus will come in case of wires. So that for that Young's modulus is nothing but this is about the length we are discussing here. Length nothing but which type of stress will come? Longitudinal stress. Which type of strain will come? Longitudinal strain only. So that longitudinal stress by longitudinal strain. Stress formula is what? Force by area. Strain formula is delta L by L. And also this delta L also known as the elongation E. We can even write it as elongation or extension. Anything is same only. Then whenever you come to the bulk modulus will be observed only in case of fluids. So for that fluids might be liquids or gases. So volumetric, the volume of the, we cannot increase the length of a gas, we cannot increase the length of a liquid. So that what we have to say nothing but we are increasing or decreasing the volume. So that what you will get here? Volumetric stress divided by volumetric strain. So that volumetric stress by volumetric strain. Whenever you are applying the force from all the directions, at that time what will be developed in the body? Pressure will be developed. Instead of taking force by area, I have taken the pressure, that's it. Force by area formula for what? Pressure only in case of liquids and then gases. Now pressure divided by volumetric strain means delta V by V. And also whenever you observe in the this one heat chapter also we will get that Charles and then Boyle's laws. We will say that always pressure is inversely proportional to the volume. Whenever we increase the pressure, then volume will decreases. Whenever from outside you are just pushing the piston with more force, at that time what happens? Nothing but the gas will get compressed. So that volume is decreasing. Pressure increases, volume will get decreases. So that, so only here pressure if I take it as positive, then volume will be negative here minus delta V by V. And also in normal cases we can take it as a modulus also. So always P by delta V by V is the formula. And also then one more thing will be there, that is called as compressibility. The compressibility C is exactly reciprocal of the bulk modulus. C is equals to 1 by B. Then whenever you come to the tangential forces, at that time you will get the shear modulus or rigidity modulus. That rigidity modulus formula is shear stress by shear strain. Shear stress is tangential force by area. This is the tangential force Ft. Tangential force by area. That divided by shear strain formula is what? Phi is equals to X by L. What is X here? Change in length, otherwise displacement. Displacement of the top surface of the body on whichever we have applied the force. So displacement divided by length of the body we have to take. That is FL by A into X, otherwise F by A into phi. F by A divided by phi. That is a shear modulus formula. These are the three modulus of rigidities of any materials. In case of wires, we will get the Young's modulus. In case of fluids, we will get the bulk modulus. In case of blocks, cubical blocks like that, we will get the shear modulus. Clear, right? Copy that. And Chandru, ನಿದ್ದೆ ಬರ್ತಾ ಇದೆ? ನೈಟ್ ಔಟ್ ಮಾಡಿದೆಯಾ? ನೈಟು ಇಲ್ಲ ಅಲ್ಲ, ಜಾಸ್ತಿ ಓದಬಾರ್ದು ಅದಕ್ಕೇ. ಏನು ಮಾಡಿದ್ರು? 11 o'clock ಮಕ್ಕಂತಾರ. ಐನ್ಸ್ಟೀನ್ಗಳು ಜಾಸ್ತಿ ನಿದ್ದೆ ಮಾಡ್ತಾರಂತ. Write neatly. Compressibility formula also you write. C is equals to what I can say? Delta V by V whole divided by P. What is E here? E is nothing but elongation. Elongation, that is equals to delta L, or extension. Anything is same only. Write a problem. It's okay, Aishwarya. Cool. ದೀಪಿಕಾ ಪಾಸ್ ಅಮ್ಮ ವಿಡಿಯೋ ಸಾರಿ. ಏನೋ ನಿಮ್ಮ ಹೆಸರೇನೋ ಸಾಕಮ್ಮ ಅಂತ ಯಾರು ಕ್ಲಾಸ್ ಮಾಡಿದ್ರೆ ಅಂದರೆ ಸಾಕು 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 ಅಂತ ಇದ್ದಾವೆ ಅಂತ. ರಘು ಸರ್ ಸಾಕಮ್ಮ ಅವ್ರ ಹೆಸರನ್ನು ಇಟ್ಟಿದ್ದಾರಂತ. ಚೆನ್ನಾಗಿದೆ ಅಲ್ಲ, ಆ ಹೆಸರೇ ಚೆನ್ನಾಗಿದೆ. ನಾಳೆಯಿಂದ ಕರಿತೀನಿ ಸಾಕಮ್ಮ ಸಾಕಮ್ಮ. ಸೊ ಹಿಯರ್ massless string of length L I have taken. Massless string of length L. One end is fixed at the rigid support, another end is hanged by a mass of how much? M. Now in that elongation, how much I am taking? Elongation is the E, and radius of this string is how much? Means that is a smaller. Radius is smaller. Now you have to determine the Young's modulus. Young's modulus nothing but what is the formula? FL by AE. So that Y is equals to FL divided by AE. So here F nothing but which force is acting on that? Mg. This is massless, by the way. The string is massless, that you have to remember. So that only force is acting mg, and that is which type of force? Normal force, otherwise tangential force. Normal force, right? Along the length it is acting, so that only we will get the Young's modulus. So here F nothing but mg is acting on the body, and the length of the string is how much? L. That divided by area, how much you will get? Pi r square. Why? Because the radius of the string is r here and the elongation is E. So that Y is equals to mgl by pi r square into E. Sometimes they will give the diameter also. So at that time we can take the diameter relation. However, how much it will come as? Pi into d by 2 it will come. D by 2 whole square. That is about the Young's modulus. In different cases, in most of the problems what they will do nothing but the length of the first rod is L, and then second rod is twice the first rod, and the radius of the first rod is half of the radius of the second rod. Otherwise diameter of the first rod is 4 times of the diameter of the second rod, like that. And then you have to find out the elongations. If those are belongs to the same material, then what happens? Young's modulus will be same only. So that what you have to find out nothing but elongation ratios, otherwise force ratios, anything. That kind of problems will come. One wire is of length L, another is of length how much? 2L. One wire is of diameter d by 4 nothing but second one is the diameter of d. They have applied by the same force, belongs to the same material. Then what is the difference is there? Nothing but their delta L will be different, elongations will be different. That elongation ratios you have to find out. If they are belong to the same material means always whenever they belongs to any chapter, I am talking about any chapter, if two objects are belongs to the same material means their density will be same almost all the time. In this Young's modulus will be same. Whenever you take in case of heat chapter, at that time thermal conductivity will be same. Clear? So in different chapters different what will be their properties will be there. Same material nothing but you have to take, those are having in the gravitation will take same density, like that. In case of fluids we will take it as a same, even in that also density is same. And also in case of heat, that will be thermal conductivity, K value will be same. You already got the formula in the this one, units and dimensions. So thermal conductivity will be same. So in case of electric fields and charges, at that time also density will be same. So different chapters, material is same material, nothing but you have to take the properties whichever you want, that will be same. And also identical, nothing but at that time you have to take as a mass also same only. Identical material, identical bodies collide with each other, like that we will take in case of collision chapter. At that time mass also same only. All the properties are same whenever it has given as a identical. Clear, right? So that is about the Young's modulus. Next one is Poisson's ratio. Poisson's ratio, not Poisson ratio, Poisson's ratio. Poisson's ratio. Asha, rub ಮಾಡಿ ವಿಡಿಯೋದಲ್ಲಿ ಕಾಣಿಸ್ತವೆ, ವೈರಲ್ ಆಗ್ತವೆ. Slowly. Yeah, the person whoever you are seeing in the video, he is Mr. Harsha TG. Feels like hero of the college. ಏನನ್ನ ಮತ್ತೆ ಸ್ಪೆಸಿಫಿಕೇಶನ್ಸ್ ಏನೈತಾ? Right. Poisson's ratio. The Poisson's ratio will be denoted by sigma. What is the Poisson's ratio means? Here whenever I have taken a rod, of diameter D. Rod of diameter D I have taken, and then length is L. Now what I am doing means I am applying a force here. I am applying a normal force. Then what happens? What happens generally? I have taken very appreciable size is there, rod size is, that is diameter D. Now I am applying a force on this. Then what happens? It really elongates. Along with that, what happens to the diameter? Decreases, right? How the length is increasing? Obviously by decreasing the diameter only, right? So that here what happens, nothing but whenever I apply the force, finally the rod is becoming as like this, thin and then longer. So diameter here, change in the diameter is delta D I will take. This was the initial diameter, this is the final diameter, this is the D dash. So that change in the diameter is delta D, and the change in the length is how much here? Delta L. Delta L is the change in the length, and then delta D is the change in the diameter. So whichever the strain produced in case of the diameter, at that time that strain we will call as lateral strain. This one is longitudinal strain, right? What is the longitudinal strain formula for us? Delta L by L. And lateral strain nothing but that is delta D by D. Lateral strain is delta D by D, and then longitudinal strain is delta L by L. Whenever we are applying a force on any wire, otherwise any rod of appreciable value of the diameter, then what happens, nothing but it will get elongates. Elongates nothing but length is changing obviously. That elongation what will take it as? Delta L, otherwise what will take here it as? E. Delta L or E. So at the same time, diameter of the wire also decreases here. Length is increasing nothing but from where that length is coming, obviously by decreasing the diameter only. So that change in the diameter is how much? Delta D. The diameter strain is known as the lateral strain, and the length strain is known as the longitudinal strain, already you know that. So the Poisson's ratio gives you the lateral strain divided by the longitudinal strain. And also whenever you observe, whenever the length is increasing, at that time what happens? Automatically diameter decreases. Whenever compression is happening, at that time what happens? Length will decreases, diameter will increases. So always both will be opposite to each other. One is increasing means another will decreases. So that the lateral strain what I can write here? Delta D by D. Decreasing or increasing? In this case decreasing it is. Diameter is decreasing, it is becoming thinner. That divided by longitudinal strain nothing but what I can say, it is delta L by L. Otherwise E by L I can take. This is the Poisson's ratio. So that Poisson's ratio is equals to delta D by delta L into what I can write here? L divided by D. Delta D by delta, see that this one only I have written just. So that minus minus L by D into delta D by delta L. So this is a Poisson's ratio, and this Poisson's ratio will have some practical and then theoretical limits. So that practical and then theoretical limits I will tell that those are also important, those values also important. And also relations between the Poisson's ratio, Young's modulus, bulk modulus and then rigidity modulus will be there. Those relations are also important, even I will teach that. So first of all, the Poisson's ratio nothing but what? The ratio of lateral strain to the longitudinal strain. Lateral strain nothing but what? That strain produced in the diameter of the wire, otherwise diameter of the rod. So that whenever the length is increasing, automatically what will decreases? Diameter will decreases. How much it is changing as? Delta D. The length is changing as how much? Delta L. So that delta D divided by D is a lateral strain. Delta L divided by L is the longitudinal strain. The ratio of those two is known as what? Poisson's ratio. If one quantity is increasing nothing but another will automatically decreases. In case of compression, what happens? Length will decreases but the diameter will increases. So only always they will be opposite to each other. This is the Poisson's ratio. Right, that Poisson's ratio. The strain produced in the diameter of the wire, the strain produced in the diameter of the wire is known as lateral strain. Lateral strain, that is delta D by D. That is delta D by D. As the length increases of any uniform rod, as the length increases of any uniform rod, diameter decreases. Diameter decreases. Write the formula. Write the formulas and then diagram everything. ఏమా కరోనా finished? So here this is about the Poisson's ratio. Poisson's ratio nothing but the ratio of lateral strain to the longitudinal strain. Lateral strain nothing but the strain produced in what? Diameter or area of the material. So that is delta D by D divided by delta L by L. And also I said that whenever the length increases, automatically what happens? Diameter decreases. In case of compression, length decreases, then diameter increases. So what will get here? Delta D by D minus delta L by L will get in case of compression. And also for this different limits will be there. The theoretical limit, the theoretical limits of Poisson's ratio or sigma is from where to where it will be nothing but -1 less than sigma less than 0.5. That is the theoretical limit. And the practical limits of sigma is just 0.0 to 0.5. Nothing but whenever you see the or whenever you substitute all the values, all the theoretical values, at that time you will get the range from -1 to 0.5, anywhere in between that. And also whenever you come to the practical limits, at that time it will be 0 to 0.5. In some of the problems they will ask, they will give some 0.7 and then 0.3, 0.2 and then 0.1. They will ask that which is the not in the limits of the Poisson's ratio. What is the answer? 0.7. Why? Because the maximum positive value is how much? 0.5. Maximum negative value is how much? -1. In case of theory or it might be in practical. So that -1 to 0.5 you have to remember that mainly. That is about the theoretical and then practical limits of Poisson's ratio. Next, factors affecting the modulus of elasticity. Factors affecting modulus of elasticity. Factors affecting modulus of elasticity. Yes, you people only tell me that whenever I raise the temperature of any body, then what happens? Elasticity increases or decreases? Increases, sure. So, observe that whenever I am increasing the temperature, then what happens? Inside of the material, what happens? Length, you just forget about the length. Inside of the molecule, what happens? Inside of the what happens? Molecules distance will increases. Then interatomic force will decreases. Interatomic force can be equals to the restoring force only. How the restoring force is acting? By the molecules only, right? So their interatomic force is decreasing, nothing but at that time restoring force also decreases. Whenever you just increase the temperature, practically also you can think, whenever I am heating some copper wire, at that time what happens? Nothing but it will get elongated only, but it cannot come back to the original size again, original position again. There what is happening means, whenever I raise the temperature, then interatomic force will decreases. As the interatomic force will decreases, then restoring force or inside force is decreasing, nothing but what happening? Restoring force also decreasing only. As the restoring force decreases, then elasticity will, what happens? It will decreases, not increases. Elasticity modulus, what is the formula? Stress by strain. Stress is nothing but what? Restoring force. I said main formula of the stress is what? Restoring force by area. At equilibrium only, that will be deforming force by area. So restoring force is decreasing, nothing but automatically what is decreasing here? Stress is decreasing. Stress is decreasing means E is equals to, what is the formula for a stress by strain? If the stress is decreasing, nothing but what happens? E also decreases. Clear, right? You got the point? So whenever you see that, whenever you are increasing the temperature, you will think that elongation increases, so that elasticity also increases, but that's wrong. What is the reason? Nothing but that elongation will be inversely proportional to the modulus here. Whoever thought like that, so many people said that E will increases immediately. Why? Because they thought that the strain will increases. Nothing but elongation increases means, if the elongation is more, you are thinking that it is having more elasticity, but that is wrong in reality. Whichever is having more elongation, that is having more strain. More strain, nothing but what happening here? Strain is inversely proportional to E. If strain is increasing, nothing but E what happens? It will decreases. So that elasticity of the wire also decreases. So only in case of rubber and then this one steel it is happening. So in case of rubber, we can elongate easily. More elongation, nothing but what happens? More strain. More strain, nothing but less elasticity. Clear? You got that point now? How steel and then rubber are not exactly what you think. So that here in rubber I can produce more strain by applying same force. For example, if I take this as a steel rod, on the steel rod I am applying a force of F. If I take a rubber of the same length, again on that also I am applying same force. So automatically whenever you see the steel rod will elongate less as compared to the rubber. Why? Because rubber will elongate more. Rubber is smoother, so that it will elongate more. So whenever it is elongating more, nothing but whenever you compare the strain of the steel and then rubber, strain of the steel and then rubber, which strain is more here? Rubber strain is more. Rubber strain is more, nothing but rubber elasticity is less. Clear? You understand, right? So that is about the temperature effect. Whenever the temperature of the any material increases, then what happens? Nothing but strain will increases. Why? Because whenever you are heating the object, at that time its length will increases. Length is increasing means automatically strain is increasing. If strain is increasing, nothing but elasticity will decreases. Why? Because both are inversely proportional to each other. That is about the temperature. Next, whenever you are adding the impurities, at that time what happens means, it will depends on the impurities added. If I add more elastic impurities, at that time elasticity of the material will increases. If I add less elastic impurities, at that time it will decreases. For example, for any material, steel will be more elastic, I said. So So that in case of steel and then iron, steel is more elastic as compared to iron. So for the steel rod, I have added more steel, then what happens, it will become more elastic. Another steel rod, I have added iron, at that time what happens, it will become less elastic. So that will purely depends on the impurities whichever we have added. Based on the impurities properties, it will either increases or decreases. Okay. Then next one is about the density. Whenever the density is increasing, at that time, whenever the density is increasing, at the time tell me that elongation will increases or decreases. Density, it is becoming as more denser. At that time elongation increases or decreases? Decreases. More denser, nothing but more thicker. For more thicker object, we can produce only less elongation. Less elongation, nothing but what it will have? More elasticity it will have. So that E will increases. Clear, right? So you just first of all write about these 3 points. Factors affecting the elasticity. First point, this temperature dependency problems also will be there, we will solve it. First one, as the temperature rises, the separation between the intermolecules also increases. Due to that, restoring force will decreases. Restoring force will decreases because molecular forces will be less. Comma, as the force decreases, as the restoring force decreases, then stress decreases. Hence, modulus of elasticity E also decreases. Underline that E decreases and temperature increases. In the next line, or as we heat the object, then it will elongates more. Strain increases. Hence E decreases. That is first line. Copy that first line. Temperature increases, restoring force decreases. This is restoring force. Decreases, E decreases. Next, when impurities are added, then the elasticity will varies with respect to the added impurities. added impurities. Next point is, as density increases, then elasticity also increases. Density increases, elasticity also increases. Even we can get the relation of the density like this. Y is equals to, what is the formula just before we got? mg L divided by pi r square into E we got. So mass nothing but what is the formula for us? V rho, right? Mass nothing but V into rho. So that I can say that V mass is V rho into G into L by area into E. Then I can say what? Y is directly proportional to rho. As the rho increases, then what happens? Y also increases. Y is nothing but which modulus? Young's modulus. And that will be in case of the lengthwise bodies. So that as the y increases, then I can say that the body is more elastic. Correct? So density is directly proportional to the E. Density increases means E also increases only. Then whenever you come to the hammering, whenever you are doing the hammering, at that time what happens? Density increases, right? They will become very closer to each other. Whenever you are hammering on an object, at that time what happens? Nothing but density will increases. Why? Because all the distant molecules will become very near to each other. At that time what happens? Density is increasing means elasticity also increases only. Whenever you are hammering the object, at that time elasticity will increases. Like that. By hammering the material, elasticity increases. By hammering the material, elasticity increases. So for example, if I take two materials, let me take the material A. On this I am applying a force F, and then whenever I apply the force F, it got an elongation. How much means delta x, otherwise xi it got. So this is the x. Whenever you compare the other material, let me take the material of B of same length initially. By the way, the length is same. It has started from the back side, right? Can you understand? This is also having same length only. This is L and then this is also L only. You just draw normally here. So I am applying the same force here. Force applied is same. Then what happening? Nothing but in this there is more elongation. This much of elongation is there. This is about by applying the same force only. Now which is more elastic? A na B na? What is the reason? Strain of A is less as compared to the B, strain of B. So the strain is inversely proportional to the elasticity, so that A is more elastic as compared to the B. You understand, right? Same like that only, that application only here it is. Now apply the force, I apply the force F so that I can produce the small elongation x1 in the material A, otherwise XA, and then I produce a longer elongation in the material XB, so that I can say that elongation of A is less as compared to the elongation of B, means XA is less as compared to XB. So elongation is less means what happens? Strain also less only, right? So that why? Because both are having initial length is how much? Same only. So here strain of A is less as compared to strain of B, and we know that the elasticity is inversely proportional to the strain. For A, strain is nothing but elasticity is more, so that EA greater than EB here. See here, strain in the A is less, so that elasticity in the A is more. Strain in B is more, then elasticity of B is less, so that elasticity of A is greater than elasticity of B. Nothing but A is more elastic as compared to B. Otherwise, B is more plastic as compared to A. Anything is same only, right? This is elastic, this is plastic. Clear, right? Write that. That is a problem. Two wires of same length. Two wires of same length and different materials. Two wires of same length and different materials are given by same load, and elongation of wire A is less as compared to elongation of B. Then find which is more elastic. TG, water takam papa. He will be always going out and then coming in. ಅರ್ಥ ಆಯ್ತಾ? ಏನು ತಗೊಂಬರ್ಬೇಕಂತ ಹೇಳಿದ್ದೀರಾ? ಎಲಾಸ್ಟಿಸಿಟಿ ಕಡಿಮೆ ಇದೆ ಅಂದರೆ ಪ್ಲಾಸ್ಟಿಸಿಟಿ ಮೋರ್ ಆಗುತ್ತಲ್ಲ. ಥ್ಯಾಂಕ್ ಯು. ನೀವು ನಮ್ದಾಕೆ ಕಡಿಮೆ ಮಾಡ್ತಾಯಿದ್ರು. ಕನ್ನಡದಲ್ಲಿ ಏನಂದ್ರೆ ತ್ರಸ್ಟಿ ದಾಹನೇನಾ? Next, write a problem. The stress strain curve of two materials. The stress strain curve of two materials P and Q are shown in the figure. Then find which material is more elastic. And important, this kind of problems are important. Which material is more elastic? Stress strain curve is given. Find that. Which is more elastic? Q is more elastic. How many of you can say that Q is more elastic? Raise your hands. It's okay, confidently you raise. Yes, almost. Why? What is the reason? Oh, you are looking like that. Strain is less and then stress is more. Slope you have to observe. Stress by strain. Okay, na? Obviously. Okay, whenever I draw like this, till here at that time what you will do? Strain constant. Strain is not constant, stress is not constant. Both are increasing only here. I am saying that Whenever I draw this one little bit longer, at that time what will say? See, the stress is directly proportional to strain. However, stress is increasing, then strain also increases only. So you have to mainly observe here tan theta, slope. So that for example, if I see the theta of P obviously is less than theta of Q, right? Theta P is less than theta Q. Nothing but tan theta of P is less than the tan theta of Q. Both I have written as, wait, tan theta of Q. So theta P is less than theta Q. Tan theta nothing but what I can write here, stress divided by strain. So that stress by strain of P is less than stress by strain of Q. Correct? Huh? Then stress by strain formula is what? Elasticity only, right? So that elasticity of P is less than elasticity of Q. That is how you have to solve. Clear? They will give number of materials here, not only PQ. They will give 4, 5 also. So that always you have to remember that EP is less than EQ. It is purely depending on what? Slope only. The slope of P less than slope of Q. That slope is giving what? Stress by strain only. Stress by strain nothing but what? Elasticity. Elasticity of P is less than elasticity of Q. So that Q is more elastic than P. Strain? Strain constant. I am not understanding your question. Strain constant. Did I say that? Strain constant ಬರಬೇಕಂತ ಇದವಾ? Even the strain is constant also. What happens at that time? Stress also will be constant by the Hooke's law. I did not understand your question. I'll clear your doubt, okay na? Don't worry about that. So here this is Q is more elastic as compared to the P. This is what we got in this problem. This type of problems are important, graph type of problems. Next one is stress strain curve. Stress strain curve based on the Hooke's law will solve. Behavior of a wire under gradually increasing load. Write that, behavior of a wire under gradually increasing load. Behavior of a wire under gradually increasing load. Behavior of a wire under gradually increasing load. In bracket, stress strain curve. Stress strain curve. Almost you might be having idea about this. Behavior of the wire. No idea about that. Whenever we are increasing the load, then what happens? The strain will increases and also stress will increases. How it will increases and all we will see. So this is stress and then this is strain. So here what happens, nothing but in this we will just take in different sections of the stress strain curve, that is up to point A and then point B. A to B something will happen and then B to C something will happen, then C to D it will be there like this, and then D to E it will be there like this. So these are known as different limits, otherwise different regions. So here O and then A. Whenever you see the O to A, what happening there? Whenever you see the line, what you are thinking about that? Straight line we got, right? Straight line starting from origin. Nothing but, can I take slope of this one? Slope is constant only, right? Constant slope is there here. So that what I can say, nothing but, can I say that stress is directly proportional to strain in this region? You are saying that it is a straight line. Straight line nothing but what I can say? Stress is directly proportional to strain. Stress is directly proportional to strain means what? That is which law? Hooke's law. Hooke's law states that stress is directly proportional to strain. So this is This under this, nothing but from O to A, Hooke's law will be obeyed. Hooke's law will be obeyed. And then A to B. From A to B, then what happens? Nothing but it will have the elastic nature. For example, if I take a wire, just understand properly, if I take a wire of length L here initially, on that wire what I have taken? Nothing but I have taken a plate. In that I can increasing the load. I can increase the load. In the plate I can increase the load here. So it is possible. Yes, I can increase the load. First of all, I have taken a mass of M on this plate. So whenever I take the mass of M, at that time what happening? Nothing but whenever I increase the stress here, mass M, nothing but what I am doing here? I am increasing the stress only by giving mg. Whenever I increase the stress, then what happening? Nothing but strain also increasing. Both are increasing at the constant level. So that what I can say, stress is directly proportional to strain. So that up to mass M, what happening? Nothing but it is obeying the Hooke's law. So this is obeying the Hooke's law up to point A. Then from A to B, what happening? Nothing but whenever I increase little bit more load, let me take this, I have taken as M1 load. Then whenever I increase M1 load, then what happens? Automatically it will get elongated. Whenever I remove this M1, at that time what happening? Nothing but it is going back to the same position again. So which nature it is having? Elastic nature. So first of all, I just checked by just putting one mass here. Whenever I put one mass, at that time stress is directly proportional to strain. As I increase the mass, then what happening? Strain also increasing only. So that stress is directly proportional to strain. So that it is obeying the Hooke's law. So only we call it as this point as proportionality limit. Why? Because until there what happening? Stress is directly proportional to strain. So it is proportionality limit. Then what happening? Nothing but I am adding one more mass here. Whenever I add one more mass, automatically what happens? It will get elongated. And then whenever I remove these masses, then what happening? Nothing but again it is going back to the length L only. So what I can say, without adding any mass, I am having how much length here? L. By adding only mass M, at that time little bit elongation is there. Whenever I remove this mass M, then what happening? It is again going back to the same position. After that, until then what happening? Nothing but stress is directly proportional to strain. After that, I increase one more mass. Then what happening? Again elongation is increasing only. But in this region, what happening? Nothing but stress is not directly proportional to strain. It is not a straight line. It is not a straight line. So that here what happening? If I increase little bit stress also, if I increase only this much of stress also, I am getting this much of strain. So both are not directly proportional to each other. Nothing but one is increasing more, another is increasing less. At that time, whenever I remove these two masses, then what happening? Nothing but wire is going back to the again original position. Nothing but up to B, what I can say? Which nature it is having? Elastic nature. At A also I am removing, let me take at each and every point we are adding one mass. Like that you just remember. So at A I am adding one mass, so that what happening? Stress is directly proportional to strain. So only we call it as which limit? Proportionality limit. And also from A to B I am adding one more mass. Whenever I remove these two masses, then what happening? Nothing but wire is going back to the original position again. Nothing but again it is coming to the origin only. So that what I can say means this one is known as the elastic limit. Up to here only the elasticity nature is there, elastic nature is there. Next, from B to C. From B to C what happening? Nothing but whenever I increase one more mass here, let me take this is point C, so that MC. Whenever I increase one more mass, and then whenever I remove all the masses here, it is not going to the original position again. Nothing but it is losing which nature here? Elastic nature it is losing. So that from B to C it is yielding or losing the elastic nature. So only we call it as yield point. Yield point we call it as. Next one is from C to D, what you can observe? From C to D what you can observe? Here there is a longer distance is there, right? So that from stress strain curve what you can say that? Observe the stress and then strain. From C to D, less stress or more stress? Less stress. See that from here to here only, very less stress, only this much of stress. But we are getting how much strain? From here to here there is more strain. From after point C, what happens? Nothing but up to point C only it will loses the elastic nature. So only we call it as yield point. After C, what happens? Whenever I increase little bit stress also, for example, I add very small value, that is MD. At that time what happening? Nothing but the elongation is very long. So that for smaller stress we are getting more strain. So that is about the point C and then D. This we call as ultimate tensile strength, otherwise permanent set. From B to D only this is permanent set only. Why? Because it is not going back again. Till where only it is going back? Till which point? Till point B only. Whenever I remove this masses from M1 and then M2, at that time what happening? It is going back. So only that is the elastic limit we got. Whenever I remove MC here, it is not going back again. So only that is in the region of permanent set. And also whenever I include little bit mass also, for example, if I include 10 grams of mass also, then there is a more elongation in the wire. So that is about which point? That is about point C to D. That is known as the ultimate tensile strength or permanent set. Then D to E, what you are observing? D to E, what you are observing from the graph? Which is decreasing here? Stress is decreasing. Whenever it is crossing some limit, whenever I remove this masses also, then it will elongate, sir. You just take the example of lead wire. Lead, you know, in soldering of the electric whatever components they will use, now lead wire. So if you take that lead wire, otherwise copper wire, whenever you are increasing the loads, at that time what happens? Nothing but it will elongate for up to some extent. After that, what happening? Whenever it is coming to the breaking point, at that stage, if you are removing the load also, it will get elongated only. So that is what this point D to E. I am decreasing the load also. Here I am decreasing the stress. See that stress is coming in the downward direction. I am decreasing the stress also. Then what happening here? Strain is increasing. I am decreasing the stress here. See that stress is coming from here to here in the negative way. Stress is decreasing. But what happening here? Strain is increasing. Whenever you decrease the stress also, then strain will increases after point D. Then after whenever it is reaching the point E, then what happens? Nothing but the wire will get braked. So only we call it as breaking point or fracture point. So after D, whenever you are decreasing the load also, then what happening? Strain is increasing. And also after that point, what happens? Nothing but the wire will get break. So only we call it as breaking point or fracture point. Okay, listen again. So from O to A, what happening? Nothing but stress is directly proportional to strain. I am adding MA here. I am adding MA. Then what happening? The stress is directly proportional to strain. So only we call it as elastic limit. Whenever I remove this MA, what happening? Nothing but it is going back to the same position again. So that it is having elastic nature. From A to B, what happening? Nothing but whenever I add one more mass, that is MB, then what happening? Strain is producing and also stress is increasing. Then both are not equal, not directly proportional to each other. And also whenever I remove MA and then MB, then what happening? The wire is going back to the same position again. So that which nature it is having? Elastic nature up to this point only. So only this is known as the elastic limit. Next, B to C, what happening? Nothing but whenever I increase MC mass, then what happening? Nothing but whenever I remove all of them, then it is not going to the original position again. So only we call it as what? Yield point. Then C to D, whenever I increase very smaller mass, very smaller stress I increase, then we are getting more strain. So only here for the less stress, we'll have there is a more strain. Then after D, what happens? Whenever you are removing the loads also, then what happening? Nothing but it is still elongating only. And at point E, what happens? It will get breaked, otherwise it will get fractured. In this regions only, based on this D to E region, this A to D region only, we will say that some of the material is ductile, otherwise it might be brittle. Whenever these two are very far from each other, at that time material cannot be breaked that much easily. Why? Because we are increasing more load here. How we are getting A to D region? By increasing the load only. Whenever I increase more load also, it is not breaking, nothing but the wire is known as the ductile material. And also whenever we are having both are very near to each other, nothing but easily I am reaching point D. After point D, what happens? Automatically it will get breaked only. So that from A to D, whenever I add only one mass also, I am reaching point D there. And after that immediately what happens? It will get breaked. It is getting breaked easily means that we known as what? Brittle material. In brittle also, anything we say brittle, nothing but what is the meaning of that? We can break it easily, right? Anything is dried or brittle, we will say that. So that A to D region is less, then that is a brittle material. A to D region is more, then we say that it has a more ductile material. Clear? Yes. You take break, and then after the break I will only take the class, we will continue. There is no need to copy anything, I will tell the notes neatly of that.